Okay, let's unpack this. For over a decade now, there's been this audacious vision. Elon Musk has talked about a future where Tesla vehicles aren't just transportation, but fully autonomous machines.
Right.
Forget the steering wheel. Imagine your car, the one sitting idle most of the day, actually earning you money, like a self-driving taxi.
Yeah, the whole asset utilization idea.
Exactly. And the material we've been looking through, it points to this really intensified push in late 2024 into mid-2025. It feels very much like a full autonomy offensive from Tesla.
It really does. It's like all the pieces are moving at once.
So today, we're diving deep into this bold strategy.
Yeah.
We're going to explore the evolution of Tesla's full self-driving software, FSD, and the huge computing muscle behind it, that custom-built Dojo Supercomputer.
Which is a fascinating story in itself.
Definitely. Then there's the planned launch of their Robotaxi service, and of course, the significant hurdles, the tech challenges, the regulatory maze, public trust, all that stuff standing between the vision and, well, reality right here in mid-2025.
It's about understanding the tech, the ambition, and sort of the state of play right now.
Yeah.
And what's really interesting is how it's not just one thing, is it? It's this tightly integrated strategy, lots of parts.
Right.
It touches on big shifts in AI, high-performance computing, entirely new ways of thinking about transport.
It's huge.
The vision is incredibly grand. Musk has consistently framed Tesla's ultimate value as being tied to cracking, large-scale autonomous cars, even general autonomous robots down the line.
He sees the potential value as, what was the word? Staggering.
Staggering, yeah. Suggesting it could make Tesla the most valuable company in the world by far. It's way beyond just selling EVs. It's about building this whole autonomous ecosystem.
Yeah.
The Tesla network.
And that network idea always included that really compelling pitch, didn't it? That your own Tesla, if it has the right gear, could join the fleet when you're not using it.
The Airbnb for cars concept.
Yeah. Generate income, add or remove your car easily. It sounds great, doesn't it? Better than just having it parked 95% of the time.
It is appealing. And, consistently talking about this long-term goal, even with all the shifting dates, it gives them a clear direction. It drives R&D.
But as you said, the timelines, they've been a defining and, let's be honest, often debated part of this whole story.
Absolutely. If you look back, the history of predicting full autonomy has been, well, a wild ride.
Totally. Early claims, maybe 10 years ago, talked about getting significant autonomy in just a couple of years.
Right. Optimistic, to say the least.
Then between maybe 2015 and 2019, the prediction for full, real autonomy always seemed to be about 2 years away, or sometimes even next year.
Always just around the corner.
There was that really specific prediction for feature-complete FSD by the end of 2019. Musk said he was certain of that, not a question mark.
Yeah, I remember that.
Yeah.
And the goals for the Robotaxi fleet, they faced similar delays, didn't they?
They did. That widely cited prediction of having over 1 million Robotaxis on the road by 2020, well, that didn't happen.
Nope.
And earlier timelines for unveiling a dedicated Robotaxi vehicle in 2023 or starting production in 2024, those slipped too.
We did finally see the Cybercab prototype, though.
Yeah.
October 2024, at that a Robot event, people actually got rides in it.
Right, but production was only hinted at as probably before 2027, so still a ways off.
So yeah, the pattern is undeniable. Aggressive targets, missed deadlines.
Yet here we are, mid-2025, and they're putting out new, incredibly ambitious targets again. Just in April 2025, we heard claims of millions of Tesla Robotaxis operating in the second half of 2026.
Millions. By late 26. That's ambition.
And FSD itself contributing significantly to profits by 2026. Plus the really immediate target, unsupervised full self-driving and consumer cars by the end of this year, end of 2025.
Right, this cycle. Ambitious claims, delays, new ambitious claims.
Yeah.
It definitely feeds skepticism for some people.
Well, understandably.
But it's also, a really powerful tool for keeping investors excited. And it drives that narrative, that story of being right on the cutting edge, always about to make this huge breakthrough.
And this aggressive timeline, this push for rapid progress, it's tied right into their core technical philosophy, isn't it? That vision-only approach.
That's the crux of it.
This is where they really stand apart from most other players.
It is. Tesla's strategy, which is pretty controversial, relies almost entirely on cameras. 8 of them, giving a 360 view. And powerful neural networks to see the world, identify things, figure out what to do, is their pure vision method.
Musk famously hates LiDAR, right? Calls it stupid, expensive, and unnecessary.
He does. points out that humans drive just fine with eyes with vision.
Which is just completely different from competitors like Waymo. They use everything LiDAR, radar, cameras, plus those super detailed 3D maps for extra safety layers.
Exactly. Tesla's betting big on just vision. Their reasoning has a few parts. They think vision, processed by really smart AI, will ultimately be better.
Better than other sensors.
That's the belief. And crucially, they see it as way more scalable, much cheaper. Cameras are cheap, right? Like maybe a few dollars each.
Compared to LiDAR, which is still, what? Around $1,000?
Yeah, even with prices dropping, it's still way more expensive. Plus, lower power use, which matters for EVs. That's another factor they mention.
And the key ingredient making this vision-only thing work, or aiming to make it work, is data. Massive amounts of data from all the cars out there.
Iterative fleet learning. That's absolutely central. By early 2025, Tesla cars using FSD had driven over 3.6 billion miles total.
3.6 billion.
Yep. And get this, 2.16 billion of those miles were added just in 2024.
Wow.
Think about that scale. In early 2025, the fleet was adding something like 8 million FSD miles every single day.
That's an insane amount of data, a huge training engine for the AI.
It is. That sheer volume from millions of different driving situations is meant to teach the AI how to handle all the unpredictable stuff, the weird edge cases you can't easily simulate.
But does it work as well as the multi-sensor approach yet?
Well, that's the big question. It's important to note, even internally, Tesla's own head of autopilot admitted in early 2025 that for tested self-driving in cities, their tech still lags Waymo by a couple of years.
Interesting. So the data engine is powerful, but maybe hasn't closed that gap yet.
It suggests maybe not fully, especially compared to systems with more sensor types. So this vision-only, data-first approach, it's fundamentally a high-stakes bet, betting that AI and data can eventually beat hardware redundancy.
A core philosophy difference, betting on software and AI to solve problems others use more sensors for.
Which brings us to a tricky point, maybe a source of confusion. The name full self-driving itself.
Oh, yeah. The terminology has caused a lot of debate, hasn't it?
A lot.
So right now, mid-2025, what customers can actually buy and use is called full self-driving, supervised.
Supervised. That word is doing a lot of heavy lifting.
And Tesla says it can drive almost anywhere, handle lane changes, navigation, turns. But the crucial part is supervised. The driver has to stay engaged, watching all the time.
That's the absolute key distinction. Despite the name FSD, supervised is technically an SAE Level 2 system. Same category as basic autopilot, really.
Meaning the human is still in charge, still responsible.
Totally. Driver is the ultimate authority. You have to keep your hands on the wheel, or at least pay close attention, monitored by that cabin camera in newer versions, ready to take over instantly.
And the features included navigate on autopilot, auto lane change, auto park, summon.
Right, and that updated, actually smart summon from 2024 lets the car navigate further, like 280 feet. Plus auto steer on city streets, traffic light, and stop sign control. All firmly level 2 stuff.
But the dream, the goal, is FSD unsupervised.
That's the target. The system that's meant to be truly self-driving, operating without needing you to constantly monitor it. The car handles everything.
So that's the leap to SAE level 4 or 5 autonomy.
Exactly. Level 4 means it drives itself completely, but maybe only in certain areas or conditions. Level 5 is the ultimate goal. Drives itself anywhere, anytime, no human needed.
And Tesla says getting there depends on, what was the quote? Reliability, far in excess of human drivers.
Yeah, demonstrated by billions of miles of experience, plus getting regulatory approval, which is a huge if.
So using full self-driving for a level 2 system? Yeah, you can see why critics say it's misleading. Could make people overconfident.
It's definitely contentious. Tesla seems to be trying to manage it now by really emphasizing the difference between supervised and the future unsupervised.
They kind of have to, right?
Absolutely necessary. The legal side, the safety bar, it's fundamentally different for a driver assist versus a truly autonomous system, which takes us inside the FSD software itself, the brain of the operation. How's it evolving?
Let's get into that. The software stack has changed a lot over the years, often tied to hardware upgrades. We went from initial autopilot hardware through HW2, HW2.5, Then the custom FSD computer, HW3, in 2019.
Right.
And now FSD Computer 2, or HW4, started rolling out in 2023, 2024. Better specs, supports higher res cameras.
And interestingly, when HW4 first came out, it was actually running software optimized for the older HW3 hardware initially.
Oh, really?
Yeah. Training the AI models to really use those better HW4 cameras took later software updates specifically tuned for it.
Okay. And then there was FSD V11, early 2023. That was a big architectural shift, wasn't it? Unified stack.
It was. Before V11, they had different code for highways versus city streets. V11 brought it all together onto one stack, aiming for more consistency.
But the really big one, the one everyone talks about that changed how it fundamentally works, that was FSD V12, late 2023, early 2024.
Yes, V12. That's where they made that significant shift towards end-to-end AI.
End-to-end AI. What does that mean in practice?
Well, reports suggest they basically replaced over 300,000 lines of traditional C++ code like a giant rulebook telling the car exactly what to do in every situation with neural networks.
So less explicit rules, more learning from data.
Exactly. The AI learns directly from watching tons of video footage of driving. Instead of following programmed instructions, it learns to output the controls, steering, accelerating, braking, just by watching. The idea is it learns more like a human, more holistically. And FSD V12.5 Spring 2024 built on that. Notably introduced hands-free driving in some situations, monitored by the cabin camera. Less need to constantly nudge the wheel.
And then V13, late 2024, early 2025, that was specifically for HW4.
Right. Trained to really leverage HW4's better cameras. V13 also aimed to bring in that park-to-parked feature.
Meaning it handles the whole trip, pulling out of parking, driving, finding a spot, parking again.
That's the goal. Full journey autonomy. And they're still integrating other safety features, like lane departure avoidance, from the older autopilot system into this new FSD stack, moving towards one unified AI-driven system.
So, okay, fast forward to now, June 2025, all these updates, V12, V13. What does it actually mean for driving? How does it perform in the real world?
Well, on highways, especially with the latest V12.6.x or V13.2.x updates, and on cars with HW4, users generally report it's pretty proficient.
Handles lane keeping, cruise control, lane changes, okay.
Yeah, handles those pretty well. Some descriptions of V13 on HW4 on highways have been quite positive. Things like mind-blowing good, needing very few interventions.
Okay, highways sound more polished. What about cities? That's always the harder part.
Urban driving. Yeah, that definitely still requires significant constant driver supervision. It's improving, but feedback still mentions behavior that's sometimes jerky and timid.
Like what specifically?
Common issues reported are things like hesitation at stop signs or before making turns, slow or indecisive lane changes, sometimes maneuvers that feel concerning, maybe pulling out unsafely or not quite obeying signs.
Yikes, there have even been reports of it trying to run red lights.
Worryingly, yes, those reports exist.
Are there specific problems that just keep popping up? Persistent challenges?
Yeah, a few seem particularly stubborn. Phantom braking, that sudden, unexpected braking for no obvious reason that's still a concern people raise.
That must be jarring.
Very. And complex intersections remain tough. Choosing the right lane, not hesitating too much, and yeah, fully obeying all traffic laws, stop signs, lights, still not perfect.
And sometimes updates even make things worse temporarily.
That happens too. Regression. There was one update, 2025.8.6, around April, May 2025, that some users reported actually degraded performance, missed exits, bad lane choices, red light issues. It shows how hard it is to get consistent improvement with these complex AI systems.
And the core weakness of vision only, that hasn't gone away.
Still the Achilles heel. The vision system is fundamentally vulnerable when cameras can't see well. Think dense fog, heavy rain, snow, low light, direct sun glare.
Right. Camera struggle. The system struggles.
Exactly. Reduces reliability. Means the driver needs to be even more vigilant in those conditions.
And how is the driver monitoring keeping up with this? Is it annoying?
The system uses steering wheel input or the cabin camera for hands-free modes to check if you're paying attention. But yeah, some users find the alerts, the nags, can be frequent. Sometimes even when they feel they are watching closely, it can be distracting.
So given all that, when can people actually expect FSD unsupervised, the real deal, level 45?
Well, as of right now, mid-2025, it's not available to the public, period.
But they're testing it.
Oh, yeah. Internally, in controlled places like factory lots, and with safety drivers on public roads in places like California and Texas, getting ready for the Robotaxi launch.
Okay, so the target for actual consumer cars is still end of 2025.
That's the tentative plan, yeah. end of 2025 in the US.
Yeah.
But it's almost certainly going to be a very cautious rollout, probably starting in limited geofenced areas.
And it needs that super high reliability, better than humans, plus regulatory approval.
Exactly. Far in excess of human drivers, validated by billions of miles. And the regulators have to sign off. And critically, you need the newer hardware. HW3 isn't powerful enough for unsupervised. You need HW4 or newer.
And the very first public taste of anything close to unsupervised FSD, that's likely the Robotaxi launch.
That's what's anticipated, yeah. The initial fleet in Austin planned for June 2025. This jump from supervised level 2 to unsupervised level 45, it's a massive leap. Legally, technically, safety-wise, huge shift in responsibility from driver to system. Requires way more validation.
All this complex software, crunching all that data, it needs serious computing power. Which brings us to Dojo, Tesla's own supercomputer.
Right.
Why did they build their own? Why not just buy more GPUs from, say, NVIDIA?
That's a key strategic move. Dojo is their custom AI training supercomputer, built specifically for training FSD's deep neural networks. The main reason? Speed. They wanted to massively speed up how quickly they could train these huge AI models.
Faster training means faster improvements.
That's the idea. Plus, building their own gives them more control over the tech roadmap, potentially lower costs long-term, and less reliance on third-party suppliers like NVIDIA, which helps with supply chain risks.
Some analysts think Dojo itself is worth a lot.
Yeah, one projection suggested it could add something like $500 billion to Tesla's value. It's seen as a key enabler.
So speed, control, cost. And it's optimized specifically for video data.
Exactly. That vision-only approach generates just insane amounts of video, petabytes, reportedly 160 billion frames a day from the fleet. Dojo is built to chew through that efficiently.
How much more efficient?
Tesla claims it's 4 times faster at video processing and uses 40% less energy per calculation compared to conventional systems for that specific task.
Okay. And that lets them train bigger, more complex AI models.
Right. Models needed to understand those tricky real-world scenarios, those edge cases.
Yeah.
It also helps their other AI stuff, like the Optimus robot. And maybe, down the road, they could sell compute time as a service, another potential revenue stream.
Okay, let's try to get a handle on the tech without getting totally lost in the weeds.
Yeah.
How's Dojo built? Starts with a custom chip.
Right, the D1 chip.
Yeah.
Designed in-house, billions of transistors, optimized for AI calculations. But the really clever part is how they combine them. They take 25 of these D1 chips and integrate them onto one big piece of silicon.
A single wafer?
Yeah, called a training tile.
Think
of it like one giant, super powerful processor with thousands of cores, all designed to work together super fast for AI training. This system-on-wafer thing allows for incredibly high bandwidth between the chips, crucial for FSD training.
So lots of custom chips on one wafer, and then they scale that up.
Exactly. Multiple training tiles go into a system tray. Multiple trays make a cabinet. And the big cluster, the exatopod, is made of multiple cabinets.
How many cores in an exapod?
Over 1 million D1 cores.
Yeah.
And it delivers massive compute power. They quote 1.1 exaflop PS. Though you have to be careful with those AI performance numbers, they aren't always directly comparable to traditional supercomputer benchmarks. Can lead to some hype.
But the point is, it's custom built and massively powerful for their specific AI job.
Precisely. Built to process that video data incredibly efficiently.
Must need a ton of power and cooling.
Oh yeah. Each training tile needs about 15 kilowatt. They needed custom power delivery systems, huge currents like 18,000 amps per tile. Reports said early tests were so power hungry they actually tripped a local power substation.
Wow.
And custom networking too. High bandwidth connections between everything, focusing on fast memory access.
So what's the real impact of Dojo right now, mid-2025? Is it actually helping FSD? And is it fully up and running?
The intended impact is faster iteration. Quicker training means they can test, refine, deploy FSD updates faster, which should theoretically lead to faster improvements in performance. FSD V13, for example, is said to have benefited from Dojo's power, letting them use even more training data.
When did it start coming online?
Well, Project Dojo was mentioned back in 2019. We saw the tech details at AI Days in 2021 and 2022. Hardware production reportedly started mid-2023. Mass production of those training tiles confirmed May 2024. So by now, mid-2025, it seems at least one full 1.1 exaflop-s exapod is operational in training models.
What about that huge claim, 100 exaflop-s by end of 2024?
Yeah, that number got a lot of attention. It likely refers to performance using a specific type of low-precision math common in AI, or maybe it was an aspiration for a much bigger future build-out, not really a standard benchmark. Shows how numbers can be hyped, need context.
And this is crucial. Tesla isn't only using Dojo, right? They're still using NVIDIA GPUs.
Correct. Very important point. It's a dual strategy. Alongside Dojo, they're still investing heavily in NVIDIA GPU clusters. They call that system Cortex.
How heavily?
Reports indicated plans to spend maybe $3 to $4 billion on NVIDIA gear in 2025, using over 35,000 of NVIDIA's top-end H100 GPUs.
So Cortex is still doing a lot of the work.
Some analysis suggests Cortex might actually be driving more of the recent near-term FSD gains, while Dojo matures and proves itself at scale for their specific needs. It's hard for outsiders to compare directly, as Dojo doesn't run standard benchmarks like MLPerf or TOP 500.
And they're already planning future Dojo versions.
Yep. Dojo 2 planned for 2026, focusing on efficiency. Dojo 3 around 2028, aiming for better performance and cost. They talk about tenfold improvements in future hardware. And importantly, they're also planning a Cortex 2.0 build-out. Suggests this dual approach with NVIDIA is likely to continue.
Okay, so all this software, all this hardware, it's all leading towards enabling the Robotaxi revolution. We finally saw the dedicated vehicle, the Cybercab, late last year.
Yes, the Cybercab. Purpose-built for their autonomous ride-hailing service, the core of that Tesla network idea, unveiled October 2024 at that We Robot event. Prototypes were giving rides.
And the design is pretty out there.
Definitely distinctive. Designed for full autonomy, so famously, no steering wheel, no pedals, just 2 seats, based on rideshare data.
And those doors, butterfly doors, no handles.
Right. Butterfly doors, no external handles, hatchback cargo area, and interestingly, no rear window, no traditional side mirrors, all cameras. Inside, just a big 20.5-inch touchscreen.
They also teased a bigger van concept?
Yeah, robovan for up to 20 passengers. Shows they're thinking about different vehicle types for the network.
What's it made of? And what's the target cost? That seemed really low.
Designed for heavy use, so durable materials, carbon fiber skin, tough plastics. And yeah, the target price is incredibly ambitious, under $30,000.
Under 30 grand, wow. An operational cost target.
Also super low, around $1.20 per mile.
How does it get that low? Small battery, efficient.
Yep, seems like it. Reportedly a smallish battery, maybe under 50 kilowatters. Prototype had 35 kilowatters. But they're aiming for close to 300 miles range in production by being extremely efficient, maybe 5.5 to 6 miles per kilowatt.
And charging, wireless only.
That's the plan for production. Wireless inductive charging. The prototypes didn't even have visible charge ports. And it'll likely share components like batteries, cameras, computers with other Teslas. Expected to have dual AI5 FSD computers for redundancy. You need that for unsupervised.
So Cybercab is the future goal, but the actual launch seems much closer, especially in Austin.
That's the big news right now, mid-2025. Austin, Texas is confirmed as the first city. And the target date often mentioned for the pilot launch is June 12, 2025.
June 12th? That's like right now.
Pretty much. Musk himself confirmed testing with paid customers in Austin by the end of June 2025.
And they're already testing with no driver inside, on public streets.
Yes. Reports in late May said driverless tests were happening on Austin streets for several days without incidents. Musk even said they were a month ahead of schedule.
How big will this initial pilot be?
Start small. Probably just 10 to 20 vehicles. And initially, they'll be using Model Ys, not the Cybercab.
Model Ys. Interesting.
Yeah. And likely employee access first, before maybe opening to the public late June or early July. But true to form, Musk has huge scaling plans. Several thousand vehicles by late 2025, then millions operating autonomously in the second half of 2026.
Millions by H226. Okay. And they're looking beyond Austin, too, Boston, New Hampshire.
Seems like it. Sightings suggest they're exploring other environments. Fits with wanting a generalized solution, not tied to detailed maps like Waymo.
How's the service actually supposed to work?
Integrated into the main Tesla app for booking rides. They'll need fleet management hubs for charging, cleaning, maintenance.
Wireless charging for the Cybercabs at those hubs.
Right, and maybe even automated cleaning robots they've shown concepts. Plus, remote assistance, teleoperation for tricky situations, especially early on, and smart dispatch systems for efficiency.
And the idea of using existing Teslas is still part of the plan.
Remains a core part of the long-term vision, that Airbnb for cars. While the Austin pilot uses Model Ys, maybe operating driverlessly under specific conditions, the ultimate goal is for FSD-equipped owners to add their cars to the network, earn money.
What about the economic disruption? Musk talks about huge profits.
If they hit those cost targets and scale up, yeah, the potential disruption is massive, aiming to seriously undercut traditional ride-hailing, maybe even make personal car ownership less appealing.
How low could the cost per mile go for users?
Discussions suggest way lower than current Uber Lyft rates, maybe well under $1 a mile. Some projections are even like $1.25 to 50 cents per mile eventually, though other estimates put it closer to the rate 81 and 81s, including profit.
And the key is that low operating cost, around $200 mile for the Cybercab, plus high utilization.
Exactly. That's the formula for high profitability per vehicle. Opens up a huge potential new revenue stream for Tesla operating their own fleet, taking a cut from owners.
ARK Invest had that wild projection, Robotaxis being like 90% of Tesla's value by 2029.
They did. Based on those economics, Musk expects FSD and robotaxis to start adding meaningfully to the bottom line by mid-2026. If it works, it could genuinely annihilate the rideshare market, change car ownership.
But there's skepticism, right, about the timelines, the profits.
Oh, absolutely. Significant skepticism from some investors, pointing to challenges like building a rider network, the big upfront investment needed for hubs, and competition. Not just from Waymo or Cruise, but maybe even Uber and Lyft eventually integrating AVs.
Plus getting permits everywhere. That's a big hurdle.
A huge one. Which brings us neatly to the major hurdles. Safety and regulation feel like the biggest mountains to climb.
They really do. In the US and Canada, FSD Supervised is out there, but regulators like NHTSA are watching it like hawks.
Continuously. There are ongoing investigations. Yeah, one PE 2480301 looking at performance when cameras might struggle sun glare, fog after crashes, including one fatal one.
And there have been big recalls related to safety.
That's right. February 2023, over 360,000 cars with FSD beta recalled over safety concerns, like not always following traffic laws. Then December 2023, over 2 million cars were called for autopilot issues after an NHTSA probe. Needed updates to controls. Alerts.
And getting permits for actual robotaxi operations is a whole other level of bureaucracy.
A totally different game. Need specific approvals from state bodies, like public utility commissions. The Austin launch might start under limited testing rules, maybe geo-fenced, maybe relying on remote help, but expanding state by state, city by city, that's complex.
How about Europe? Rollout seems slower there.
Yeah. Musk admitted stricter EU rules slowed things down. But there's hope that new UNES rules in September 2025 might allow more advanced highway features, maybe hands-off, eyes-on. They're still aiming for a broader FSD supervised rollout in Europe in 2025. Sounds like they're actively working on it.
And China, FSD Supervised launched there.
Yeah, launched and reportedly well-received. Despite challenges with data rules initially, Tesla sees that as a positive sign for launching in other complex markets.
Okay, let's talk straight about the safety record. Tesla often shares data showing autopilot FSD is safer than humans.
They do. Their Q1 2025 report, for example. One crash per 7.44 million miles with autopilot FSD on versus 1 per 1.51 million miles off.
Yeah.
Compared to the U.S. average of 1 per 702,000 miles.
Yeah.
They use this to argue it's safer.
But there are major critiques of that data, aren't there?
Huge critiques. Widely argued it's not an apples-to-apples comparison. Critics say autopilot FSD gets used mostly on simpler highways, which are inherently safer anyway.
Right. Not rush hour city traffic.
Exactly. And crucially, Tesla's public data doesn't show how often the system disengages, how often the human has to take over, or near misses. You need that for a real safety picture.
And NHTSA is still investigating lots of crashes where it was reportedly engaged.
Yes, including fatal ones.
Yeah.
And advocacy groups like the Dawn Project compile their own stats claiming high numbers of crashes and deaths, though you have to consider their advocacy role.
What about independent studies? What do they say?
More mixed. The IHS gave autopilot FSD beta a poor rating in 2025 based on their tests. But another study, looking at YouTube drives of V12 V13, noted big improvements, fewer disengagements, smoother driving, but still saw errors. It's just really hard to benchmark fairly.
And those edge cases, still a problem, especially for vision only.
Still a challenge. Tesla's strategy is more data, simulation, synthetic data, Dojo's power, end-to-end AI. Throw everything at it to handle the unpredictable. But critics insist vision only will always struggle with certain visual ambiguities, weird objects, bad weather.
And recent errors like running red lights or turning onto train tracks even in good weather.
Yeah, those reports raise questions. Are they rare edge cases or do they point to more fundamental issues? Interestingly, there's talk of advanced radar, Phoenix radar, maybe being used on some HW4 models, possibly for robotaxis. Could be a pragmatic nod towards needing some redundancy for truly unsupervised driving.
Beyond the tech and the rules, there's public perception, trust. That seems like another huge hurdle for this offensive.
Massive. Public feeling is really mixed, polarized. You've got the huge enthusiasm, but also deep skepticism. A lot depends on performance, but also commentary.
Media coverage hasn't always been kind.
Often focuses on accidents, investigations, missed deadlines, Musk controversies, which fuels negative views.
And surveys show people are wary.
Yeah, data shows significant trust issues. That April 2025 survey, 44% distrusted the Tesla brand overall. Only 51% thought the cars were safe. And specifically on autonomy, 71% said they wouldn't ride in a Tesla Robotaxi.
71%. That's huge.
It is. And Musk's public profile, the controversies, that also impacts trust in the brand and tech.
And the marketing names themselves, autopilot, full self-driving, they haven't helped build trust.
Widely criticized for being misleading for Level 2 systems, safety advocates worry it encourages overconfidence, misuse, which leads to incidents which further erodes trust. It's a cycle. High-profile accidents really hurt public confidence.
So pulling back, looking at the big picture, this full autonomy offensive isn't just hype. It's a real concerted push on multiple fronts at once.
It really is. The push on FSD software with V12, V13, end-to-end AI, scaling up Dojo and NVIDIA compute power, taking concrete steps for robotaxis with the Austin pilot, the Cybercab development, it's all interconnected. A focused, ambitious, high-stakes play.
And success really depends on navigating all these challenges simultaneously.
Precisely. Getting the tech reliable and safe enough, way beyond human levels, getting regulators everywhere to approve it, and crucially, getting the public to trust it enough to actually use it. That's the trifecta they need to achieve. Mid-2025, especially with this Austin launch, it feels like a really critical moment. We'll see if the vision starts matching reality.
Okay, so let's recap this deep dive. We've seen this incredibly ambitious, multi-pronged approach from Tesla, pushing FSD software hard with AI, fueling it with data, and massive compute power from Dojo and NVIDIA.
Right.
All aiming to launch this disruptive robotaxi service. Starting with that Austin pilot using Model Ys, with the purpose-built Cybercab on the horizon.
It's a vision that, if it works, could genuinely change everything. Transport, car ownership, cities. But as we've discussed, the path is incredibly difficult.
Technical complexity, regulatory hurdles, public trust, huge obstacles remain.
Massive. Getting the tech safe enough for unsupervised driving in all conditions, getting approvals globally, winning over public confidence after years of hype and incidents.
So what does this all mean for you listening to this?
Well, Tesla is fundamentally betting its future, its massive valuation, on cracking this, on achieving true unsupervised autonomy at scale. The next few months, especially watching that Austin pilot and tracking progress towards consumer FSD unsupervised by year-end, they'll be crucial indicators.
Will the offensive succeed, or will the real-world challenges prove too much for now?
Exactly. It's not just about watching cars drive themselves. It's watching a potential massive shift in mobility, asset value, city life.
It definitely makes you think. How good would a Tesla robotaxi need to be, how proven, before you would feel comfortable hopping in and letting it drive you?
Yeah. And if the cost really does drop as low as they hope, how does that change your view on needing to own a car at all? The tech race is accelerating, Dojo and all that, but safety, regulation, and human trust, that's still the core puzzle to solve.
Fascinating stuff. We'll definitely be keeping a close eye on how this all plays out.